All right, so this question we need to start by first combining everything that is like terms on one side of the equals and combine everything that is like terms on the other side of the equals. Okay, so here's what we have. We have 6 minus 4x. All right, so on this side, there's no more combining of like terms. We have a number and we have one with a variable. So these two are not like terms. Now on the right-hand side, we have a 6x and a minus 8x and then a minus 2. So this 6x and this minus 8x, those two things are like terms. So when we take that and combine those two, 6x minus 8x is the same as 6 minus 8 with an x on it. So 6x minus 8x is minus 2x. All right, and I'm going to rewrite the left-hand side again. Nothing was like terms on the left-hand side. And now we have the minus 2. All right, we just bring it straight down. There's no like terms. There were no other numbers, just numbers without variables on the right-hand side. So now we combine like terms across the equals. So what I mean by that is we have a negative 4x on this side, and we have a negative 2x on this side. So there's several ways to go about doing this. And that's part of what I think confuses some people at this step in algebra. They don't know where to go from here because there's two different paths you can take here, right? You can add 2x to the right-hand side, or you can add 4x to the left-hand side, and it doesn't matter. Either way, you're going to get x's eliminated on one side. So I want to eliminate some x's from one side and get them to the other. And now some teachers have shown students always move the x's to the left-hand side and move the numbers to the right, and that's fine if you're familiar with that. Just to show you that you can do it either way, I'm going to move the x's to the right-hand side. So when I say move the x's to the right-hand side, I'm going to do this, again, the equals is the big dividing line. Whatever I do on the left-hand side of that red line, I need to do it on the right-hand side. So if I have minus 4x, what's the opposite of minus 4x or subtraction of 4x? It's add 4x, right? And so as I start to work these problems, I actually line up the x terms and the number terms to make this a little bit more clear. So I realize that negative 4x plus 4x, when I do that, I get 0. All right, and then we have 6 plus 0 or minus 0, it doesn't matter. But anyway, we typically x through that and say, look, that canceled out. It's no longer there. That 0 doesn't change what's on that right-hand side. Now, what has to happen here is if I add 4x to the left-hand side of the red, I've got to add 4x over here too. So I'm going to come right here and write a plus 4x. That's the whole basis of algebra, is that whatever's done on the left-hand side must also be done on the right-hand side. That keeps all the mathematics happy. All right, so now I have, again, this is kind of like what we did up here, combining like terms. I have negative 2x plus 4x. So again, we treat that as negative 2 plus 4, and then apply an x to the end of that. So negative 2 plus 4 is 2, and then we write x. And then we'll go ahead and bring down this minus 2. So now I have the statement 6 equals 2x minus 2. Now I'm going to do the same thing with the number part. All right, so now when we want to go solve an algebra problem, we typically need to get x on one side and the numbers on the other. All right, so what I'm saying here is now once I've moved the x over here to the right-hand side, once I have x on the right-hand side, at this point, I can subtract 6 here, but then that will give me, that's not going to help me. What I want to do here is now, since I've moved the x's from the left to the right, I want to move the numbers that are on the right to the left. All right, so I'm going to add 2 right here, because the opposite of subtract 2 is to add 2. And again, whatever I do over here, I got to do it over here too. And now I can, in fact, draw a line all the way across there. And so by doing that, negative 2 plus 2, again, is 0. I'm not going to write the 0 this time because we know now that 0 doesn't change the outcome. I'm just going to X that out and say, look, negative 2 plus 2 means that that side no longer has any numbers on it. And this side has 6 plus 2 equals 8. So we have 8 equals 2x. So if I bring that problem over here, and so now we look and we say, all right, I have 2 times x, and I want to get x. So what's the opposite of multiplying something by 2? I need to undo that, right? To undo the multiplication of 2x, I need to do the opposite. of multiplication by 2, which is division by 2. And see, 2 divided by 2 is 1, x, right? Or just x. So I get just an x on the right-hand side, and then so whatever I did here, I need to do it to both sides. So I divided by 2. I need to divide this side by 2. And so 8 divided by 2, we can simplify that. 2 goes into 2 one time. 2 goes into 8 4 times. So I'm left with a fraction 4 over 1. And the fraction 4 over 1 is just the same as the number 4. And now, of course, you can come up here and check this if you like to see if this is true. Once you get more confident with this, you don't have to check every time, but I think now is a good time to check. So if we put 4 in where we see x, it should make a true statement. So let's try it. 6 minus 4 times, and there was an x there, so we're going to put a 4, equals 6x, x is 4, minus 8, again x there, and it's 4, minus 2. So this is 6, and then negative 4 times 4 is negative 16. Here I have 6 times 4 is 24. Negative 8 times 4 is negative 32, and then minus 2. If I come down here and keep writing, 6 minus 16, again, at this point, check this with a calculator if you want to. Do this with a calculator. There's no point in trying to make this any more difficult than it has to be. Just put in 6 minus 16 on your calculator and get negative 10. And then here, do the same thing, right? 24 minus 32 minus 2, and you'll find that that is also negative 10. And so we get a true statement. Negative 10 equals negative 10. If you did it wrong, let's say you got, for some reason, you got x equals 5 or some other number. If you put 5 in here for x everywhere, you'll get two numbers that are not equal. All right, so anyway, in this case, when we put in 4, we got a true statement at the end, so we know that x equals 4, and that's what you'll type in the box.